Okay, this is warm up 916 for period 4. Make sure you show all this work and write down the 5 words to show me that you listen. The first 2 problems are exactly the ones we did for the classwork on the 14th, except I'm plugging in a different number. But here we go. Write all this work. Write down the words. This is the math that you have to know how to do. All right, so here we go. They're going to tell you what the first term is. They're going to list it for you just to make sure that you know that that 8 is not the 0 term. That is the first term. So I'm going to have you label these. I want you to be able to see what I'm doing to these numbers on top. It looks like I'm adding by 5, adding by 5 each time. That makes this be a straight line. That makes this a linear sequence. This is arithmetic. You have to know all of that just by seeing that once it's adding by 5 each time, that's arithmetic. Now I could use that 5 to do the opposite going to the left to find that 0 term which I need for my y-intercept. So the 0 term, if I take that 8 minus 5, 8 minus 5 gives me that 0 term, which is 3. Here I go. What you need to know, the recursive answer, you have to know how to write it. The recursive answer is f of x equals f of x minus 1 plus 5. That is the recursive function you have to know how to do. The explicits, you will have to know both explicits. The first one is f of x equals that same 5 times x plus the 0 term, that f of 0 term, 3. That is one that you could use. That is the most common one, the slope-intercept form one, mx plus b. The other one, which is more high-tech, you could use that same 5, but instead of using the 0 term, I could use the first term, but I got to make sure that I write right here x minus 1 plus that 8. I want you to know that these are both equivalent. Even though using the 0 term or the first term, those equations look exactly or completely different, they are the same. They are equivalent. If I was to distribute this and get 5x minus 5 plus that 8, it gives me the same exact equation as that other one. That's why when you plug in to both of these, you always get the same answer because they're equivalent. First word is gray. Gray. I wanted you, for full credit, to plug in both numbers into both to show that they both give you the same answer. So here we go. I'm going to put those into use. In use. I'm going to plug in 25. So for this one, plug in 25 for x. That just shows I'm plugging in x is 25. Right here is where I actually plug in the 25 and do some math. That gives me 5 times 25, which is 125, plus that 3 shows me that when I plug in 25 for x, the y number gets spit out as 128. You could write that as a coordinate if you wanted to. That would be the coordinate 25 for x up 128 for y if you really needed to graph it. The next one should give me the same answer. If I take this one and plug in 25, should give me the same answer. So I got my 5 here. I'm plugging in 25 right here for x. That's going to be taking away 1 plus 8. That gives me 5 times 24 plus that 8. 5 times 24 on my calculator. Don't trust my arithmetic. gives me 120. And there it is. 120 plus 8 gives me that same value at 125 for that other one, 128. Know that both will always give you the same answer because they are technically both equivalent. All right, let's move on to the next one, geometric. So this one, again, they tell you what the zero term is. I'm sorry, the first term. They tell you the second term and the third term. This one is not adding, subtracting. This one is timesing. Timesing by 2. Timesing by 2. As soon as you see that timesing, it's a curved line. It's what we call exponential. You could also call it geometric. I could use that timesing 2 to go the opposite direction, which is dividing by 2. This 3 divided by 2 gives me 3 over 2. But remember, making it more complicated, we don't divide by 2. We show dividing by 2 as timesing by the reciprocal of 2, which is timesing by 1/2. But no matter what, going back to that zero term, timesing 3 by 1/2 gives me 3/2, or 3 divided by 2 gives you 3/2. So no matter what, that zero term is 3 over 2. That is the zero term. If I wanted to write recursive, f of x equals f of x minus 1 times 2. That is recursive. Rarely going to use it. Explicits, which we're going to use a lot. Explicits, here we go. You could get any answer by timesing the zero term times that r number raised to the x power. Or, of course, you could use the first term instead, which is a nice, neat whole number 3 times that same 2, but you got to write that to the x minus 1 power if you choose to do that. Here are both of them in use. Finding the fourth term, which should make sense, should be 36 if I do that correctly, the fourth term. So here we go. Let's see. Let's plug in 4 for x. That again just shows me the value I'm plugging in for x. Here is where I plug in the actual value 4 and do the math. 2 to the 4th, you're timesing 4 of those 2's. Gives me 16. Never would that give me 8. That's 16. So that's 3 over 2 times 16. You could put that over 1 times 3 times that 16 gives me 48. I'm sorry. 3 times 16, yes, gives me 48. And if I divide that 48 by 2, it gives me 24. Yes, that's really what I should have got. I'm not sure why I put 36 up here. Should have been 24. That 12 times 2, 24. There it is. That gave me the fourth term is 24. It gives me 48 over 2, which divides to give me 24. Next word is black. Black. All right, the other one should give you that same 24 if I plug in 4 right here. So plugging in 4, this has 3 times 2 to the 4th. Oh, I'm sorry, not 4. 4 minus 1 power gives me 3 times 2 to the 3rd. 2 to the 3rd, you're timesing 4 times 2, that gives me 8. So this ends up being 3 times 8, which you could see a little bit easier because no fractions in there, but give you that same fourth term of 24. Have to know how to do this with my help or another teacher's. All right, let's move on. Next problems you have to know how to do. This one, again, where I give you the first term and we're going to have you just give explicit and recursive. This one, if you look at it, a little bit harder to see what's going on up here. But if I look at my smaller numbers, I could see that this is being divided by 2, being divided by 2. But remember, we don't show it that way. We show dividing by 2 as timesing by the reciprocal, timesing by the reciprocal, timesing by the reciprocal, timesing by a half. 24 times a half is 12, which means for this one, if you're back stepping to that 0 term, you're taking 192 and timesing by the whole number 2. 192 times 2 gives me 384, and that makes sense because starting out with 384 and then dividing by 2 gives me 192 dividing by 2, so that is my 0 term. So here I go. Recursive. Just write it. For this problem, you're just writing them. Times 1/2, not plus, not dividing by 2, timesing by a half. Explicit. I could either use my 0 term, 384, times that r number, 1/2 to the x power. Or if I want, make sure on test day you choose one. Don't try to get fancy and show me both. Choose one. I could use the first term instead, 192, times that same 1/2, but to the x minus 1 power. That is the second way. On test day, choose one of these. You don't want to try to get fancy and show both. That's when I see mistakes. Choose one to use. All right, next word is blue. Blue. All right, keep going. Next problem you have to know how to do. This one, where I tell you the first term is -62. For these, the only way that you're going down in negatives is if you're subtracting, which means I'm really adding 13. Adding 13. That's the only thing that makes these negative numbers go down. Adding 13. Adding 13, which means if I'm going back to the 0 term, I'm subtracting 13 from this -62. So -62 minus 13 gives me -75. Write the equations. Recursive. Plus 13. Explicits. I'm going to write both, but on test day, you choose one. I could do f of x equals that slope number 13x minus the y-intercept, the 0 term. Or I could use f of x equals that same 13 but times x minus 1 and subtract not the -70, the -62. And again, even though these look completely different, if I was to distribute, they would end up being the same. 13 times x, 13x, 13 times -1, -13. If I take 13 and 62, it should give me that -75. They are the same. That's why when you plug in a value for x into both of these using the 0 term, this guy right here, or using the first term, always will give you the same answer. All right, almost done. This one, have to know how to do. Next word is tan. Tan. For this one, they give you the first term. They tell you the first term is 5. They tell you what you're timesing each one by. You're timesing by 3, timesing by 3. So take that 5 times 3 gives me 15. Take that 15 times 3, and that gives me 45. Take that 45 times 3, gives me 135. Don't forget, 135 times 3 gives me 405. Those are the next 4 numbers in this sequence, starting with the first term being 5, and knowing that I'm taking all the other terms and keep timesing by 3. 3 is the timesing number. All right, last problem. You will need to know, second to last for these. This one is going up by 6. That makes this straight line linear, we're going to call it, which is, of course, arithmetic. This one going up by 2, and then going up by 3, and going up by 4 is neither linear or exponential geometric. This one, timesing by 3, timesing by 3, is going to be a curved line, exponential or geometric. And then the last one, up by 2, up by 2, looks like another linear straight line, arithmetic. All right, gotta know those. Last problem. If I give you a table, you need to be able to write the function from this table as well, recursive, both forms of explicit. Looking at this y column is really the f of x. This is the column. You're looking at the numbers going up. That is your slope number. That is your d. That is your number that you could use to backtrack to find that 0 term up the column. So if I take 7 minus that 3, it will take me up the column to that all-important 0 term right there, 0, 4. If I had to write my equations for this table, recursive plus 3, my explicits, which are even more important, would be f of x equals that 3x plus 4, the y-intercept term when x is 0. Or I could use, of course, and you pick one, don't do both, 3 times x minus 1 plus not that 4, but that 7, knowing that even though those look completely different, they really are the same. If I was to distribute that, that would give me 3x minus 3, and that minus 3 and that plus 7, guess what? Give you 3x plus 4. They are the same, even though they don't look like it. All right, last problem this is, and the last word is red. Red. Use these problems to help you with the handout that I'm collecting today. Good luck. See you next week. I will try to help you best I can.